Thank you so much for the introduction. So the introduction has been made. I'm going to add that my journey from university to my current role has been shaped by a deep passion for technology and strong focus on applying practical and innovative solutions to real-world challenges. And also, my work in QA automation allows me to continuously learn and applying what I discovered directly to real projects and ongoing challenges. So what I want to share with you today is not just something we are building, but our vision, how we plan to use AI to reshape our testing processes. This is not only about saving time or working faster, it's about building smarter systems that grow with our needs and support our goals. During this presentation, we will explore the current challenges, the strategy we are implementing, the benefits it brings, and how it can evolve into something even more powerful. So, what's the challenge? In fast-paced development environments, time is everything. But as we release more features, we also generate more test cases. Some are useful, some are outdated, but all of them need attention. Unfortunately, manual testing teams sometimes can't keep up with this growing volume. The process slows down, feedback is getting delayed, and bugs may slip through production. Even though our continuous integration and deployment tools are fast, our manual review process has room for improvement. That's why we are looking for AI tools to help us quickly sort through test cases and highlight which ones are best for automation. Here's the idea. We want to build a smart AI-powered systems that review all our documented test cases, evaluates how suitable they are for automation, and creates tickets for the most promising ones. It's like having a reliable assistant that reads through thousands of test cases, understands the content, and highlights the most valuable ones to automate. This means QA engineers spend less time manually reviewing and more time writing high-impact automated scripts. To implement our idea, we are leveraging models like OpenAI's GPT-4 and Google Gemini. These tools are capable for understanding structured documentation. They can read through test titles, steps, and expected results, and then break them down into 4 scoring categories: complexity, determinism, repeatability, and dependencies. Each test case is scored using a weighted formula where more emphasis is placed on complexity and determinism and slightly less on repeatability and dependencies. Some test cases are clear, predictable, and repeatable, making them ideal for automation. Others, which involve variation or complexity, may be less optimal and better handled through manual testing. This system makes test case selection more objective and scalable. Instead of depending only on individual judgment, we also get consistent, data-driven recommendations on which tests are worth automating. It's not just about picking the easy ones, it's about focusing on value, minimizing delays, and keeping our automation aligned with our business priorities. Let's see how it works. The AI doesn't just say yes or no to automation. It performs a structural analysis across the 4 core areas mentioned: how complex the test is, how predictable the result is, how repeatable the test can be, and what external factors it relies on, like specific environments, databases, or third-party services. In addition to scoring each individual test case, the AI also recognizes patterns across its test suite. It can detect duplicate or overlapping cases, highlighting consistencies in structure, and suggest improvements for test case clarity. These insights will help improve the overall quality of our test documentation and not just automation coverage. Let's see an example. First, it's a login test case. It usually involves a simple form and a clear expected result, like success or failure. Also, it can be tested many times with different inputs. It's predictable and stable, so that makes it a great candidate for automation. On the other hand, imagine a test for a live pricing widget on a trading platform. This test depends on real-time market feeds, updates frequently, and behaves differently across time or accounts. It's much harder to predict, reproduce, or simulate, so it's flagged for manual testing. The scoring system emphasizes simplicity and determinism for a more reliable automation. AI generates a combined score based on key factors and flags complex or unclear cases for review, helping us maintain high quality and improve continuously. These scores feed into dashboards that categorize test cases into high, medium, or low automation feasibility. This helps team leads quickly spot high-value opportunities and identify cases that may need refactoring. Altogether, this transforms automation planning from a guessing game into a repeatable, data-backed strategy that improves both automation potential and test case quality. Once the AI scores a test, we want the system to automatically generate a ticket in our project queue. This ticket will include the test case title, its automation score, the AI's recommendation on whether to automate, and the suggested testing framework. It will also include implementation suggestions, so engineers have a starting point. This approach reviews repetitive manual work and ensures every high-potential test case is captured and tracked in a structured way. Manual testers are still actively involved in this process by validating AI suggestions, annotating exceptions, and updating the ticket if special conditions apply. This shared visibility improves cross-functional collaboration and builds trust in the AI's recommendation. Rejected cases are automatically backed up and flagged for future review. These are revisited during sprint retrospectives or when tooling capabilities expand. By connecting AI-driven evaluation, automated ticketing, and manual reviewer input into a unified workflow, we are creating a feedback-driven loop that strengthens accountability, increases transparency, and accelerates automation adoption at scale. Now let's talk about how can we track our progress. We are going to store all this data, like test case scores, automation statuses, and execution results in a centralized system and monitor everything using visual dashboards. These dashboards will provide real-time visibility into our key metrics. For example, we can track how many test cases have been reviewed by AI, how many were approved for automation, how many tickets were generated, and how many tests are actually being automated. We will be able to slice the data by project and test type, making it easier to identify progress and spot delays or gaps. We can monitor KPIs like automation time, which is how long it takes for a manual test case to be fully automated, and automation coverage, which is what percentage of all tests are automated versus manual. This helps us react early, and if we notice that the automation rate is slowing down, or a team has too many pending cases, we can then step in. We can also set alerts for when coverage drops below a certain threshold, or when specific areas are consistently left out of automation. With these insights, our QA strategy becomes more proactive and data-driven. We can plan better sprint goals, boost our team's productivity, and continuously improve our automation roadmap. We are building the strategy using tools that are already part of our workflow. Currently, we use TestRail to manage and document all our test cases, Selenium and Appium for our core UI and mobile automation testing, and Jenkins to handle CI/CD pipelines and trigger automated test runs. TestRail acts as our central test case management system. Using its API, we will extract the test cases and feed them into the AI engine, which will then process and analyze each one based on its structure and content. Once the AI scores a test, the Jira API will create a ticket for our automation team, including all the useful information like the score, the type of the test, and a clear description of how the automation can be implemented. We will then store all this data in a PostgreSQL database and visualize it using a Grafana dashboard, enabling us to continuously monitor performance, track coverage, and make informed decisions with confidence. So what's the real impact? AI gives us clarity and speed. It removes repetitive tasks so testers can focus on what really matters, thinking critically, exploring edge cases, and improving quality overall. Automation engineers get cleaner and more actionable work. Product teams get faster release cycles, and our QA process becomes smoother and easier to scale. At the end of the day, we can say that AI helps us move with confidence and make smarter choices faster. AI doesn't take over the team, it supports it. Our goal is to find a reliable setup that balances speed and accuracy while delivering clear and structured results. Right now, we are developing this strategy by experimenting with different AI models and building scripts to analyze structured test case data. The next step is to make the system available through Slack with a chatbot, so testers can ask the bot to review a test case on the spot and get back instant feedback, including a suggested automation score and the option to create a ticket. This Slack integration is just the beginning. We see it as a foundation for even more intelligent, accessible, and seamless QA tooling in the future. This kind of integration will make it easier for teams to act quickly, stay aligned, and move test cases through the automation process more efficiently. In the long run, we see this as a way to build a more flexible, collaborative QA process where AI supports daily work and help teams stay focused on what matters most. Thank you so much for listening. I would like to hear your feedback and questions. No, currently we are implementing this strategy by using public models, but it's a foundation to start and build a custom model to make it tailored to our needs.
Because if you use public one, you need to expose your code to the public available.
It's not exposing the code actually. It's exposing the test cases. So.
But in order to write the test case, it needs to see the code or not?
Not exactly. We can provide it with.
Processes and the thinking of how it should work and so on. How do you provide this information to the model?
We can provide it with the project specifications and not actually giving it the source code. Okay. Yeah. Oh, sorry. Thank you.
In your example, we saw TestRail integration as a test management system.
You mean here?
So would it be possible to integrate with other test case management systems?
Actually, we use TestRail to have our test cases gathered in one place.
Okay, so it's not used in the whole cycle at all?
Actually, it's used by, we are using its API to export the test cases, okay. But outside of that, the test cases feed into the AI engine and then proceed to the automation process.
So you could probably support any other management system supporting APIs?
Yeah, of course.
Okay, cool. Thank you.
Do we have any other questions? No, I
We
think
have 1 hour
Yes.
there.
we have one more. Yes.
I would like to ask about the pricing of that, calling the OpenAI or the Gemini.
About the pricing, what do you mean exactly?
Call the API, you have some pricing to call the API and get the response, or
As a company, we already have a license
yes?
for its API. So I think that is the answer for that question.
Okay.
It's not both of them. We're actually testing both of them, but eventually we are going to use one of them. But in the future, maybe have a custom model, so we won't actually need to pay one of these two companies.
Because as of my knowledge, I know that for every call you have to pay.
Okay. It's based on the prompt that we are using for this. So this prompt, actually, we structure a prompt to manage to have the less cost of the results.
Okay, so you optimize your prompt so you get one answer for many things, and then to no.
Can you
Yes.
give more detail?
No. Okay, it covered.
We can cover it outside if you want.
Ah.
Yeah, because we are ahead of our time, I think.
Okay. Yes. I'm coming. I don't know if you can hear me.
I can hear you.
Yes. Oh, I asked because if you do you optimize your prompt, so you do the less amount of API calls to Gemini or OpenAI.
Yes, correct.
Okay.
Yeah.
It's talking. Yes.
I think we are okay now.
Yeah.
Thank you very much, Stefanos. That was a great presentation.
Very happy to be here.